Hello, my name is Dr. Jim Senger. I'm an R&D director here at CTC, and we're standing inside our chemistry lab. The purpose of our chemistry lab is really twofold. It's first off, it's to do quality control testing on incoming resins, as well as to look at new next generation type of resin systems that would improve our product. I'd like a chance maybe to talk about some of the equipment we have here that we use on an everyday basis to do the two functions I just mentioned. The first is our refractometer. As the name would imply, the refractometer measures refractive index of resins and hardeners. We use this as a quality control tool. When new resins come, ingredients come into our shop, we'll examine every batch, every lot of material. We'll get samples and we will place the sample on the refractive index cell. We'll close the cell and turn the light on, and by looking through the eyepiece, we can determine the refractive index of the product. We have a specific range of acceptable refractive indexes. So if the test results goes outside that range, we reject the batch. But most of the time, the specimens are within the range and we accept the lot. So that's the refractive index tester. The next item I'd like to talk about is our gel timer, which is down this way. So our gel timer measures the gel time of our resin, which is important for our process. This is what we use to measure the time it takes for a resin to gel. And in that essence, we measure the reactivity of the resin system. So first off, we would set this instrument to a specific temperature that we wish to test at. We would mix up our resin sample and then place a small amount of that sample onto the tester. By using a spatula or some type of stirring device, we then stir it and measure the time it takes for the resin to gel. And again, we use this as a quality control tool to look at the reactivity of our resin before it goes out into processing. So again, that ensures that our resin has the specific reactivity that we need to make the part that we make. The next thing I'd like to discuss is our microscope that we'll look at, where we look at the resin fiber interactions, which is this way. The next piece of equipment I'd like to talk about is our microscope. Which is shown here. We have a polishing wheel and a microscope. We use this to examine the interactions of the resin and the fiber in our core, especially when we're looking at new resin systems. So when we want to examine the interaction of resin and fiber, we will take samples of core that we've made and we will place it on the polishing wheel till we get an infinitely fine polished surface. After the sample is prepared, we'll place the sample underneath the microscope. We use the microscope to look at the interactions of the resin and the fiber just to ensure we have good bonding of the resin to the fiber, which would ensure that we have good performance of our part. So again, by looking at the resin fiber interactions, we can ensure that we have good bonding and which would ensure good performance of the part. So that's our microscope. The next piece of equipment I'd like to show you is our Brookfield Viscometer, which is this way. Brookfield Viscometer, as the name implies, tells us the viscosity or the thickness of the resin that we're using. Again, this is another quality control tool that we use. Anytime we get any of our resin ingredients in, we often will use the viscometer to check to make sure that the resin viscosity is in the acceptable range that we've set. It's a very simple test. The sample goes into this sample cell. We'll weigh out a specific amount. We'll place the sample cell into the temperature chamber. We use this, we measure viscosity at a specific temperature, usually at room temperature 25 degrees Celsius. We'll then attach our spindle. We'll insert the spindle into the resin and attach it to the viscometer. We'll turn on the spindle, and as the spindle rotates, the instrument will measure the viscosity or the thickness of the resin. The test takes maybe 5 or 10 minutes to equilibrate. But again, afterwards, we ensure that the resin has the proper viscosity that we need for production. So that's our Brookfield Viscometer. So the next piece of equipment I'd like to talk about is our high-performance liquid chromatograph, which is right next to it. Chromatography is an old chemistry technique. It's been around for quite a while. It's a process where molecules, different types of chemicals can be separated from one another. This is another quality control tool that we use. We'll take a resin mixture that we've prepared, and just to ensure that the the resins are mixed properly, we'll inject it into our chromatograph, which will again separate the chemicals. And then we can get a quantitative measure of one chemical versus the other to ensure that we have the right mix ratio. So we inject the resin into the chromatograph. It goes through this separation column, and then it goes through our detector, which indicates the presence of the molecules as peaks. And we measure either the area of the peak or the height of the peak, and again use that as a ratio of one peak versus the other, and again that ensures that we have the proper mix ratio of our resin. So that is the equipment we have in our chemistry lab. Again, they're all very effective tools to measuring not only quality control of our process and our raw ingredients, but also helps us to develop new resin systems for maybe future core. Thank you for listening.